You ask a modern AI a simple question. It only requires a 3-sentence answer. Instead, the model generates a sprawling 15-paragraph essay. Engineers attempt to curb this verbosity through prompting or stricter length penalties. These fixes address the symptoms, while the root cause remains buried in the model's fundamental relationship with data. Large language models operate on a principle of epistemic flatness. Inside the high-dimensional vector space where tokens live, the system lacks an innate hierarchy of importance. A life-saving medical fact and a piece of etymological trivia occupy the same plane of value. Without a mechanism to distinguish signal from noise, the transformer architecture is structurally incentivized to output everything. It drowns the user in information that is technically true but practically useless. This flatness is a legacy of the math that built the digital age. In 1948, Claude Shannon established the bedrock of modern computing with his mathematical theory of communication. Shannon defined the fundamental engineering problem as the reproduction of a message. To achieve this, he explicitly stated that the semantic aspects of communication, the meaning or effectiveness of a message, were irrelevant to the technical problem. 76 years of information theory has successfully optimized for accurate reproduction. We have reached the limits of transmission, but we have largely ignored how to mathematically evaluate the utility of the data being transmitted. Our most advanced machines possess near-perfect fidelity, yet they have no epistemic judgment. They cannot decide if a transmission is actually worth the user's attention. The industry currently relies on reinforcement learning from human feedback, or RLHF, to align AI behavior. RLHF uses a 3-tier system to categorize data: good, neutral, and bad. Because the reward signal is a single scalar value, accuracy often gets conflated with agreement. Human raters tend to reward comprehensive-looking output, creating a mathematical basin of attraction that favors sycophancy and bloat. This framework has a fatal missing piece. It contains no mechanism to identify information that is true and safe, but entirely wasteful. While modern information theory excluded the effectiveness of a message, the Islamic intellectual tradition formalized it. Scholars developed a value function for knowledge that explicitly penalizes the non-beneficial. The assumption that all knowledge is inherently good to transmit is what creates the verbosity trap. To resolve it, we need a taxonomy that can triage truth itself. This alternative architecture begins with the prophetic concept of ilm nafi, beneficial knowledge, versus ilm la yanfa, or knowledge that does not benefit. This isn't merely a spiritual aspiration. It is an operational constraint for systems with finite processing capacity. Information that provides no actionable benefit is a burden. It consumes the scarce resource of attention without producing work. In the 11th century, Imam Al-Ghazali systematized this constraint into a formal 5-tier taxonomy of knowledge. Within this framework, truth without utility is active noise. The goal of the system is to reduce the entropy of the communication by filtering for benefit. This taxonomy creates the knowledge triage lattice, a 5-tier governance structure that replaces the standard RLHF model. Tier 5 is Fard Ein, task-critical truth. This is the information the system must provide to satisfy the user's primary objective. Tier 4 is Fard Kifaya, safety warnings and critical caveats the user did not ask for, but which are necessary for their preservation. Tier 3, Mustahab, covers enriching details and analogies, to be included only if the context budget allows. Tier 2 is Mubah. This is the innovation modern AI lacks. Mubah is information that is true and permissible, but confers no benefit to the specific user in their specific context. The Mubah suppression principle gives the system a formal directive to withhold true but useless information. Finally, Tier 1, makruh or haram, represents harmful, misleading, or sycophantic content that is blocked unconditionally. These tiers are governed by the niyya, or intent filter. As the system detects the user's purpose, it dynamically reclassifies every token in the candidate response. By providing a formal permission structure for silence, the lattice resolves the overgeneration failure mode that scalar rewards cannot reach. Take a common, high-stakes medical query. What is the recommended dosage of ibuprofen for pain relief? A standard model typically returns a 420-token response. It buries the dosage under the drug's patent history at Boots Chemists, its molecular mechanism, and generic disclaimers. The knowledge triage lattice identifies the historical and molecular data as mubah. It classifies these facts as non-beneficial to the user's immediate objective and suppresses them. The result is a 77% token reduction. The model delivers a 95-word response that retains all task-critical data and safety warnings. This moves beyond a length preference. It is a semantic classification engine that surgically removes noise while preserving the signal. Implementing this hierarchy requires more than a simple system prompt. To truly fix epistemic flatness, the lattice must reach the transformer's underlying architecture. At its deepest level, the lattice stratifies the model's embedding space. It allows the system to weight context tokens by their triage tier, ensuring critical information maintains its priority. This also addresses context decay, the phenomenon where models forget earlier instructions in long context windows because of attention dilution. Here, we turn to the Islamic legal principle of istishab, or the presumption of continuity. This principle holds that a known state persists until evidence establishes a change. Integrating this presumption provides a Bayesian prior for state persistence. It creates a mathematical floor that prevents established facts from fading out as the attention mechanism scales, countering the natural decay of the transformer architecture. Modern AI alignment is built on ad hoc principles and crowdsourced feedback. The knowledge triage lattice is built on 1,400 years of adversarial scholarly debate. The tech industry is currently blind to the post-Enlightenment assumption that more data is always better. In an era of infinite generation, we need a formal entropy reduction function. We need a way to protect the finite resource of human attention. The future of artificial intelligence isn't found in teaching machines to speak more. It is found in discovering the mathematical